Hi there, my name is River Gallen,
And I'm Brooke Bradish.
and today we're going to be talking about our Biz 441 Computer Applications and Finance final project. And the scope of this project was to create a statistically optimized portfolio of 20 stocks using the past 5 years of historical returns. The stocks we chose to use in this project was Microsoft, AMD, the Indian Country ETF, EPI, MAA, which is the Mid-America Apartment Communities, a REIT, Palo Alto Networks, MasterCard, Shopify, JP Morgan, Tesla, Home Depot, MGM, Uber, General Dynamics, Caterpillar, NextEra Energy, Google, Netflix, Albemarle, First Solar, and Meta. What we did first was using the stock history and stock data function in Excel was get the past 5 years of prices for all the stocks. And from there, we then in turn created the natural logarithmic returns for the past 5 years. And then we found the average returns, average standard deviation, and average variance for all those returns as well. And then using the average returns or the mean returns, we found the excess returns, which is a crucial function or crucial matrix to have for the covariance matrix of the stocks, which is pretty much the correlation of each stock with another stock for the entire portfolio. This function we will call S. And this was found using the matrix multiplication function, transposing the excess returns times the excess returns, and then dividing it by n-1 because it's a sample. Then with the correlation matrix, we then use the Cholesky decomposition function to find the lower triangular matrix of the Cholesky of the covariance matrix. And that's essential really to find the correlated returns that we use in our stocks. And to get those correlated returns, we first get a normal distribution of the random values, find the correlated z values, which is another matrix function using those normal distributed random values. And then with those correlated z values, we then turn those finally into our correlated returns. Using these correlated simulated returns for the next 5 years, we then were able to create our optimal risky portfolio. And this is a function, another matrix multiplication function, which really takes advantage of the ability to use large data sets, but it was taking the matrix multiplication of the inverse of our correlation matrix times the transposed value of our expected returns minus the effective rate of interest. And it's really essential to do that part because without including the effective risk-free interest rate, you're not going to get your optimal risky portfolio. And then you pretty much divide it by the sum of those values, the exact same thing, but just dividing it by sum to get an equal 100% weighted portfolio. From that optimal risky portfolio, we then averaged out what our portfolio values would be if you started with a $10,000 balance when you were 22 years old. So with our example run right here, which is only one run, if you had started with a $10,000 portfolio value, you would have ended up, in this case, with around $260,000. To find that risk or to find the account balance, we needed to first get our risky portfolio return, which is just multiplying our optimal risky portfolio weights by our simulated return values for each year, for each month in this case. But obviously, the risk-free rate is essential to have in our portfolio. And this was found using a mean reversal process, which pretty much states that it'll go up and down, but never really leave the long-term mean, which you can see right here as mu. And of course, there's phi's pressure, which is kind of like how much up and down it will go in the graph. And then obviously sigma right here, very, very low for the risk-free rate as well. And in our portfolio, we also modeled that once you turn 42 years old, we decided to increase the weights of the risky portfolio starting when you turn 40, actually, that it will increase to 5%. And then every year after that, it will grow another 3%. And then finally, with that one run of our portfolio values, as you can see right here, we created a Monte Carlo simulation of around 1,000 runs, but in this case, it created 10,320,000 different values, which, speaking statistically, it means that out of all these values, you're going to be able to find a portfolio that's the most common, the one that you can count on, that will be the most likely value that you'll have at the end. And right here, we also chose, we did another simulation saying, like, if you were to withdraw money at X age, what would your portfolio values be? And the probability right here of having over $1 million by 65, as you can see, it's 1.4%. And unfortunately, our portfolio did not make it to 2 million by 65, at least in our runs. Obviously, if you do more, there's a greater chance to have a higher percentage in your portfolio. And then right here, the probability of having at least $1 million in your portfolio with the withdrawal is around the same percent, so it doesn't make that much of a difference. And with the $2 million withdrawal as well, it's as well as zero because we didn't get a $2 million portfolio value.
So based on our findings, we organized our information into 3 dashboards. So this first dashboard is based off of the money distribution. And this first chart that you see right here, we have money distribution by risky and risk-free weights. So we did that by multiplying our portfolio ending value each year by the risky amount weights and the risk-free amount weights. So as you can see, at age 65, there will be more money invested into the risk-free amount than the risky amount because the weights were increasing. And so you could see at 65, the sum of the risk-free amount was about 70,000 versus the risky amount was close to 20,000. And we have inserted a timeline so you can kind of interact with that to get the sum of risk-free amount and risky amount by the year that it is. And so this next graph, we have our risky and risk-free return by age, which kind of just demonstrates how the risky portfolio return value fluctuates a lot throughout the simulation, and then the risk-free return stays pretty constant. So you can see that some of these values are up to like 40% return, but it can also be down to like negative 40% return. And so this next graph over here, we have our account balance beginning and ending. The blue indicates the beginning balance and the orange indicates the ending balance. And we have inserted a filter by age. So in this case, we have at age 23, we starting with 141,000 and we end with like probably like 2,000 or 3,000 more than that. So you can kind of play around with that and just see the beginning and ending balance by age. And so then our next graph we have here is the average portfolio. Our next dashboard that we have is a based on our probability outcomes for our Monte Carlo simulation. So you can see the table to your left has the maximum portfolio value for each run that we did, our mean, minimum, and median. So at age 22, you only have 10,000 invested in there, but that fluctuates as you reach age 65. So for that first graph, we have up there the most likely outcome probability. And so we decided to use the median and mean value just to show you 2 different kind of values and outcomes that you can have. And you can see at the time that you're 65, the probability is pretty fluctuating between your median and mean value. And then, so for this graph, we have our average portfolio value, our best, worst, and most likely outcome. And you can see that that kind of is a big range for our maximum value. It's up to 150 trillion, versus our mean value and minimum value are a lot smaller than the maximum value. So that kind of just shows the different probabilities with our Monte Carlo simulation. And so then our next graph dashboard that we have on here was our stock information. And so we sorted that into different graphs based on the risk of the stock return. And so you can see there's some pretty risky stocks, including Tesla, Shopify, AMD. And so those kind of fluctuate. And then our stock return, Tesla has the highest stock return, which makes sense because it also is the riskiest stock. AMD has a pretty high return, same with Microsoft. And then this next graph is our best to worst performing stocks. So I kind of sorted it from left to right based on the highest return and also the lowest risk as well. So Tesla has pretty high return, high risk compared to MAA, which has a pretty low risk, but also low return as well. And so then these pie charts that we have to our right show the different initial weights by ticker. So we have our short position and our long position and how our risky portfolio is weighted between each of these stocks based on our optimal portfolio and our Sharpe ratio. So that is our final project, and it was a very good simulation to kind of see that if we invested $10,000 by the age that we are now, we can see what kind of probabilities we have if we invest into these different stocks of our risky and risk-free portfolio.
All right, well, thank you for listening to our project, and I hope you have a good rest of your day.